Hello, parents. This is Chris Allen. I am your son or daughter's Calc BC teacher, and I wanted to give you a quick update for this week, October 5. This week, we're looking at the logistics differential equation, and I wanted to give you kind of an application today so we kind of get away from some of the abstract material we've been doing and give you something that's a little bit more application-based. A state game commission releases 40 elk into game refuge, and after 5 years, the elk population has grown to 104. The commission believes that the environment can support no more than 4,000 elk. The growth rate of the elk population, P, is given by the differential equation dP dt equals Kp quantity 1 minus P over 4,000, where T is in years. Question A is to write a model of the elk population in terms of T. In other words, question A is asking us to solve this differential equation. And then B asks us to graph the slope field for the differential equation in a solution that passes through the point 040. So the good news is that in my video that I shared with the students, I actually show them how to solve this logistics differential equation. So I'm going to go ahead and skip to that on our next slide. So to write this in terms of T, we know that the solution of that particular differential equation is y equals L over 1 plus b e to the negative kt. There's a lot of variables in there. So what we can do now is use the information that's given to us in the problem. We are given that the initial population was 0, 40. In other words, at time t equals 0, there were 40 elk, and the CP, that's the carrying capacity, is 4,000. So what we can do is we can actually substitute that into the known general solution for that differential equation, which gives us the following equation. We can then solve this for B, and it turns out that B is equal to 99. So the constant B is 99, so we can replace that in our original equation. Notice now that the L is 4,000, that's our carrying capacity, and B has been determined through an easy calculation to be 99. Next up, we know that the population of elk at time t equals 5 years is 104. So I'll use the 0.5, 104. Again, we'll substitute that into our known solution. So t is 5 here, and the population is 104. We can solve for k. K is approximately 0.19436. And that gives us the particular solution for this problem with the carrying capacity of 4,000. Notice that the only variables here are y and t. So you give me a time t, and I can tell you, based on this model, what the population of elk would be in that particular refuge. So we could graph this using a graphing calculator, which would produce this interesting looking graph here. This is called a slope field. And then I want to draw a curve that passes through the point 040, which I've done in pink. And this gives us some idea of what we should expect in terms of the growth of the population of elk in this refuge. So this is just a neat application of differential equations. Some final thoughts here. Number one, E of Q, end of quarter, is this Friday, October 9th. End of quarter. Any missing work needs to be turned in before the 9th. I've announced this the last 2 weeks, and I've been reminding the students as well. Also, I'd like to mention that we have a new bell schedule happening October 19th when we return from fall break. That bell schedule, we will return to a 7-period day. So it's going to be a faster pace. I will post that bell schedule in Canvas for the students to look at. Keep in mind, though, that that means that students are going to be going 2 days a week instead of just 1 day a week. Hybrid students. And finally, I would just like to encourage your students to enjoy their break. If they don't have to work and they don't have to do a whole bunch of stuff, I would just encourage them, if they've been working really hard, to just really relax as much as they can and get some much needed rest. Thanks for their hard work. Thank you for your attention, and have a great fall break.